Every second, billions of lights remain illuminated. Factories continue operating. Hospitals remain active. Financial markets process transactions. Satellites communicate. Cloud servers answer requests. Artificial intelligence generates predictions. Modern civilization appears effortless, almost automatic. But beneath every digital interaction, there is another system working continuously, an invisible machine stretching across continents. Power plants generate electricity, transmission lines transport it, substations regulate it, distribution networks deliver it, control centers balance it, thousands of operators coordinate it, millions of sensors monitor it. Every second, supply and demand must remain almost perfectly balanced. Too little electricity, entire regions can lose power. Too much, equipment can fail. Unlike many resources, electricity cannot simply be stockpiled at massive scale across an entire civilization. It must be generated, transported, and consumed almost simultaneously. This makes the electrical grid one of the most complex engineering achievements humanity has ever constructed. It is not simply infrastructure, it is a living system, a machine that never sleeps. Because before civilization can become digital, it must first remain electrified.
Most people imagine electricity as a simple journey. A power plant generates energy, a cable delivers it, a building consumes it. Reality is far more sophisticated. The electrical grid is a hierarchy. Generation creates electricity. Transmission moves enormous quantities over long distances. Substations transform voltage. Distribution networks deliver electricity safely to homes and businesses. Above every physical component, another layer exists: digital control systems, forecasting software, protection mechanisms, load balancing algorithms, weather prediction, demand modeling, real-time monitoring. The modern grid has become a cyber-physical system, part industrial infrastructure, part software platform. Millions of decisions occur every minute. Where should electricity flow? Which generators should increase production? Which transmission corridor has available capacity? Where is demand rising? Where is maintenance required? The objective is not merely producing electricity. It is orchestrating one of the largest synchronized systems on Earth. Every successful moment goes unnoticed. Only failure attracts attention. And perhaps that is the greatest achievement of infrastructure. When it works perfectly, it becomes invisible. When it disappears, civilization immediately notices. Who owns the electrical grid? The answer is more complicated than most people imagine. There is no single switch, no global control room, no corporation operating the world's electricity. Instead, the grid is a federation of systems. Power plants may be privately owned. Transmission infrastructure may belong to regulated utilities. Distribution networks may be operated by regional companies. Control centers may coordinate independent operators. Governments establish regulations. Markets determine prices. Engineers maintain stability. Software orchestrates millions of decisions. Ownership is fragmented. Responsibility is distributed. Control is coordinated. This architecture evolved for resilience. If one component fails, others continue operating. If one company changes, the network survives. The strength of the electrical grid has never depended upon centralization. It depends upon interoperability. Thousands of organizations, operating under common technical standards, following synchronized engineering principles, sharing responsibility without sharing ownership. This is one of the defining characteristics of modern civilization. The most important systems are rarely owned by one institution. They are coordinated by many. Power in the modern world is increasingly exercised through architecture, not absolute ownership.
For more than a century, electricity was managed primarily through physical infrastructure: generators, transformers, transmission towers, mechanical switches. Today, another layer is rapidly emerging: software. Modern electrical grids increasingly rely on predictive algorithms, digital sensors, machine learning, real-time optimization, automated protection systems. Every second, millions of measurements enter sophisticated control platforms: voltage, frequency, load, weather, equipment health, demand forecasts. The objective is no longer simply generating enough electricity. It is continuously optimizing an enormously complex system. Artificial intelligence is beginning to forecast equipment failures before they occur, predict renewable energy output hours in advance, optimize power routing across transmission corridors, reduce energy losses, balance fluctuating demand. The electrical grid is quietly becoming one of the world's largest software-defined infrastructures. Physical assets remain essential, but increasingly, software determines how efficiently those assets perform. The future grid will not simply deliver electricity, it will continuously calculate, predict, adopt, and optimize itself. The age of mechanical infrastructure is giving way to the age of intelligent infrastructure. For decades, electricity demand followed relatively predictable patterns: population growth, industrial expansion, urban development. But artificial intelligence introduces an entirely new variable: compute. Every AI model requires computation. Every computation requires processors. Every processor requires electricity. And every improvement in AI capability increases computational demand. This creates a new economic relationship. Electricity is no longer simply supporting the digital economy. It is becoming one of its primary production inputs. The factories of the Industrial Revolution consumed coal. The factories of intelligence consume electrons. This transformation extends far beyond data centers. Semiconductor fabrication, cloud infrastructure, autonomous vehicles, robotics, scientific computing, digital twins. Everything depends on reliable electrical capacity. The AI revolution, therefore, becomes an energy revolution. Countries capable of expanding electrical infrastructure efficiently may also become leaders in artificial intelligence. Because algorithms alone do not create competitive advantage, infrastructure does. The next great technological competition may not begin inside laboratories. It may begin inside substations, transmission corridors, power generation facilities, and the invisible electrical architecture supporting them all.
Every technological revolution eventually encounters a bottleneck. The steam engine needed railways. The automobile needed highways. The internet needed fiber optics. Artificial intelligence is discovering its own constraint: electricity. The world's appetite for computation is accelerating faster than many electrical infrastructures were originally designed to support. New hyperscale campuses require enormous amounts of continuous power. Semiconductor fabrication plants demand exceptional electrical stability. Cloud providers continue expanding. Entire industries are becoming increasingly electrified. The challenge is no longer simply producing more electricity. It is delivering the right amount to the right place at the right time without compromising the stability of the network. Transmission infrastructure can take years to plan. Permitting requires coordination. Construction demands enormous investment. Grid modernization is measured in decades. Artificial intelligence, meanwhile, evolves every few months. For the first time, software innovation is beginning to outpace physical infrastructure. This creates an extraordinary imbalance. The digital economy can scale almost instantly. Electrical infrastructure cannot. The next generation of technological leadership may therefore depend less on writing better algorithms and more on building better grids. Because computation cannot exist without power, and power cannot exist without infrastructure. The invisible constraint of the AI century may not be intelligence itself. It may be the ability to deliver electrons precisely where intelligence is manufactured.
Infrastructure has always attracted long-term capital, not because it grows quickly, but because civilization depends upon it. Roads generate movement, ports enable trade, telecommunications connect economies, electrical grids power everything built above them. As artificial intelligence expands, electricity becomes even more valuable, not merely as a commodity, but as productive capacity. Every additional megawatt can support factories, data centers, manufacturing, digital services, scientific research, and future industries that have yet to emerge. This changes the investment equation. Energy infrastructure is no longer viewed solely as a public necessity. It is increasingly recognized as strategic economic infrastructure. Governments invest, utilities expand, private capital finances modernization. Technology companies participate directly. Entire ecosystems begin forming around the expectation that computation will continue growing for decades. Infrastructure becomes a platform supporting thousands of industries simultaneously. The greatest returns may not always come from building the newest application. Sometimes they come from owning the foundation upon which millions of applications ultimately depend. History has repeatedly rewarded those who built the roads before everyone else began traveling them. The AI economy may reward those who build the electrical highways that intelligence itself will travel.
For more than a century, electricity flowed in one direction. Power plants generated energy. Transmission lines transported it. Consumers used it. The system was largely predictable. But the 21st century is changing that architecture. Solar panels now generate electricity from rooftops. Wind farms produce variable output. Battery systems store excess energy. Electric vehicles consume and potentially return electricity. Factories increasingly optimize consumption automatically. Artificial intelligence predicts demand before it occurs. The electrical grid is no longer simply distributing power. It is coordinating millions of independent decisions. Every smart meter becomes a sensor. Every transformer becomes a data source. Every substation becomes part of an intelligent network. Electricity is beginning to behave less like a utility and more like information. Energy flows can be forecast. Demand can be optimized. Equipment failures can be anticipated. Maintenance can be scheduled before breakdowns occur. Entire regions can coordinate electricity with unprecedented precision. The grid is evolving from a mechanical network into a computational system, one capable of sensing, learning, adapting, and continuously optimizing itself. Just as the internet transformed communication through software, the smart grid is transforming energy through intelligence. The future electrical network will not simply deliver power. It will think about where power is needed before the demand even arrives.
History often remembers wars, leaders, treaties, and elections. Yet beneath every geopolitical transformation, infrastructure quietly determines what becomes possible. Industrial revolutions were powered by railways. Global trade expanded through ports. The digital economy emerged through fiber optic networks. The intelligence age is being built upon electricity. Every nation speaks about artificial intelligence. Every nation speaks about technological competitiveness. Every nation speaks about digital sovereignty. But none of these ambitions exist without infrastructure. The ability to generate electricity, transmit it reliably, expand capacity, modernize aging systems, and integrate new technologies. The competition is no longer limited to economic growth. It is increasingly about infrastructural readiness. Which countries can sustain exponentially growing computational demand? Which regions can support hyperscale manufacturing? Which economies can expand without destabilizing their electrical systems? These questions rarely dominate headlines, yet they quietly shape the trajectory of global competitiveness. Infrastructure creates optionality. Optionality attracts innovation. Innovation attracts capital. Capital accelerates infrastructure. The cycle repeats. The nations that understand this relationship are not simply investing in electricity, they are investing in the productive capacity of future civilization. Because the most valuable infrastructure is rarely the one everyone notices. It is the one that silently enables everything else.
Every civilization is ultimately constrained by the systems it can build. Roads determine the reach of empires. Ports determine the scale of commerce. Railways determined industrial expansion. Telecommunications determine the speed of information. Today, electricity determines the speed of intelligence. Every algorithm begins with energy. Every cloud platform depends upon the grid. Every autonomous machine, every semiconductor factory, every financial exchange, every hospital, every research laboratory, every digital service exists because an invisible network continuously delivers power with extraordinary precision. The electrical grid is not simply another utility. It is civilization's circulatory system, a system carrying the energy required for every higher layer of the modern economy. Artificial intelligence may redefine industries. Robotics may transform manufacturing. Quantum computing may unlock entirely new capabilities. Yet each breakthrough ultimately returns to the same foundation: reliable electrical infrastructure. History teaches a consistent lesson.
The greatest economic transformations rarely begin with consumer products. They begin with infrastructure. Infrastructure creates capability. Capability enables innovation. Innovation reshapes civilization. The organizations that build applications may capture attention. The organizations that build platforms may capture markets. But the systems that build infrastructure capture dependence. And dependence compounds into enduring influence. The future will not be decided only by who invents the smartest artificial intelligence or who launches the next revolutionary platform. It will increasingly be shaped by those capable of designing, financing, modernizing, and operating the invisible systems that allow every other technology to exist. Because electricity is no longer simply powering civilization, it is powering the architecture of the future. The strongest empires of the 21st century may not be recognized first by the height of their skyscrapers or the size of their economies, but by the resilience of the invisible networks flowing beneath them. Because long before intelligence becomes software, before software becomes industry, and before industry becomes wealth, someone must first build the grid. Nixera, decoding systems, architecting wealth.